So, welcome. My name is Mark Bolinsky. This is Renan Lourenco. We're going to be here talking about a preview of where we're thinking of going with HealthShare and containerization. By no means do not hold us to anything that you may see in here, but this is where the thought process is currently going. We do have a goal for the fall release to have some portions of it. We're initially going to be targeting uh, our patient index, but we'll get into more detail. So again, this is just a preview. We'd love to hear some feedback. So any questions you might have during or afterwards, please just let me know. So, okay. So I already introduced this. So first of all, I'd like to discuss what is cloud native. You might hear this term used a lot. Um, we're also going to talk about kind of a phased approach that we're going to be taking with HealthShare because we certainly don't want to be boiling the ocean in one shot. So it's going to be an iterative process, and there's going to be growing pains and learning curve as we go through the process. We will be showing a demo of where we're currently at. Again, it's a little more than a proof of concept, but again, just to show you where we're thinking and where we intend to go. So from this, you learn, what is our approach currently and what we're thinking of going with containerization, because containerization is a loaded term. Anyone here today using containers at all? Anyone using HealthShare? Yeah, I was gonna say. So it's one of these, right? um, uh, and also, we'll start giving you some advice as to how to think about using containers with HealthShare, because there's situations where it's really good for it, and other situations where yes, you can do it, but doesn't mean you should do it. So we're going to go over a lot of those different scenarios. So again, let's unpack cloud native. So really, what is it? Again, as I mentioned, it's a loaded term. Here's what CNCF actually defined it, and I'm not going to read it all here, but some key highlights is really the choice of cloud, um, whether it's Azure, on-prem, private cloud, hybrid, um, your choice, and that's really one of the key differentiators. Um, Also, it's a mutable infrastructure and it's a declarative configuration, because right now, as those who have HealthShare today, sometimes it can be quite a challenge to manage very large HealthShare federations where you have dozens, if not maybe even hundreds of different namespaces out there. Um, where containerization and the declarative nature of it with YAML files, it really helps clean that up and put standardization around it where it can be a repeatable process for deploying HealthShare. And with that, well, one thing I want to point out is I didn't highlight containers here specifically because one, we're talking about it, but B, also being cloud native, and I can't stress this enough, being cloud native doesn't automatically equate to containers. So containers does not equal cloud, and cloud does not equal containers. So I want to be very clear on that. Although it's a very common delivery mechanism of using containers in cloud, and it's great. And I'm not here to say don't do it, but again, I just want to make sure that it's not a one-to-one relationship between them. Um, and then I can't stress enough is the automation capabilities. Is having that ability to repeat a deployment, standardization of codes, implementing uh, configuration hardening, if you will, in standards. So that way, if you're deploying a number of edge gateways, they're repeatable every time you deploy a new edge gateway in terms of configuration settings within the CPF file, maybe pool sizes, maybe standard code that you might load in terms of standard interfaces that you may have. All of that can be included and incorporated in the standard deployment model. So here's an example of what we have today. You deploy here. It's an example in Azure. A lot of virtual machines. There's I don't know how many here, 10 or so. So you'll have your clinical viewer. You may have multiple edge gateways. The registry ODS may or may not be in there. You might have patient index, health insight. So each one of these boxes here would represent a separate virtual machine within a given deployment, whether it's in Azure, AWS, or even on-prem. A lot of moving parts. So our initial approach, or maybe what we're calling phase 0, is taking HealthShare kind of as is. So as I mentioned earlier, we want to take a phased approach, crawl, walk, run. You hear that term used a lot. Is we really want to ease into it, learn from it, because HealthShare is a very, very big application, and there's a lot of complexity that comes with it. So we're going to be focusing on Docker and Docker Compose initially. I'll talk about Kubernetes in a little bit. And when I say here, it's planned for the 2022.2 release this fall. Again, that's no guarantee of all components, some components. So it's, again, where we're thinking of going. So it's a very active process for us right now. So if there's any plans for something that you have might upcoming, certainly let us know. We'd love to hear about your plans. But I just want to, again, keep the caveat clear. So a couple key points as to when we started down the path. So unlike Iris Data Platform and Iris for Health and Health Connect for that matter, which are currently available today in container forms, we're going to be using Red Hat's UBI, or the Universal Base Image 8. Instead of Ubuntu, I think it was a 20.04. Maybe it's being upgraded to something else as well. But we're standardizing on Red Hat 8 for now. May change again. So again, that star caveat saying that things may change. But the thought here is, because the majority of our install base right now is Red Hat based. It's a good mix between Red Hat, Windows, and AIX. And although unfortunately there's no containers for AIX at the moment. So we're going to be slated for Red Hat UBI 8. They will be pre-built images. It'll be a one-for-one relationship. So as you have the standard HealthShare install kits today, so if you go on the WRC page, the distribution page, you'll see all the various kits for a specific version. The thought is we'll at least what we're thinking of right now, is have a one-to-one relationship. So for the UCR and patient index kit, there will be a UCR plus patient index container image. It's just a base image. Nothing's yet deployed in it. Now, down the road, we may split that up even further to make the containers more streamlined and lightweight, where there'll be a specific, here's the registry container, here's an access gateway. Again, that's to be determined, but these are some of the things that we're thinking about as we go down the process. But as I mentioned earlier, again, the power comes into declarative configuration capabilities of it, automation, repeatable configurations, and that's really where containers is going to really shine for HealthShare-based deployments. So as we think about HealthShare as is, we have categorized these into 3 different types of containers. And what I mean by that, so we have ones that we'll call them horizontally scalable and elastic, possibly, with using load balancer. These are things like your access gateways, clinical viewers, the IHE bus, web servers, and maybe ESB routers to a point. But again, a single interface you can't have horizontally scaled because you need to maintain FIFO. But those are the types of things that we would consider elastic and horizontally scalable. Then there's, in the middle tier here, is what we have our edge gateways and document repositories. Those, I would say, are quasi-elastic and horizontally scalable, meaning you would deploy them as you need them. As you add more data sources and data source providers, you add more edge gateways. Same thing with document repositories. As you fill one up as much as you want, or if you want to add more for different facilities, whatnot, they would horizontally scale out. And then there's what I call them, static, but meaning that they can only scale vertically. These are things like the registry, provider directory, patient index, although we're working on some things for patient index, horizontal scaling, ODS, and so forth. We're going to see this graph a couple times more in the presentation, because it's important to see how these are going to apply in just a container-based deployment, and also what it potentially would look like in a Kubernetes-based deployment. So, as I mentioned, we're going with 6 different base image types based off the installer kit. We may look to bust them up again, but essentially it's having that one kit to match the container image. One thing to note is on this list here. So we have Health Connect. It already is available today as a container image. I do have Personal Community and the new Action Engine up here as well. There are no current plans explicitly at this moment, but that will be something we look into at a future release for as well. So, okay, so now what? We have these container images. So what are we going to do with them? So as I said, so phase 0, we're going to be using Docker and Docker Compose. It's the lowest common denominator with that. And what I mean is kind of the gateway or the first step into a Kubernetes or an ECS or GKE type deployment. It's got to be running in containers. So using Docker and Docker Compose is that first step to getting there. Phase 1 and beyond is getting into the more exotic, potentially, whether it's Kubernetes or not, that remains to be seen. Whether we use Kubernetes or just use Amazon ECS as an example, where it's just an elastic container service, might actually be a better footprint or delivery mechanism for it. Because as you know, the HealthShare customers know today, a given instance type or namespace typically monopolizes the entire machine, where Kubernetes and Kubernetes nodes, the benefit there is you can have a lot of pods. A pod is a container or more, and running all on the same physical machine. We tend to monopolize and maximize the machine there, but there's different scaling capabilities we can go into. The other benefit of using Kubernetes is getting to use our IKO or our Kubernetes operator as well, where it does a lot of this stuff behind the scenes within Kubernetes, creating labels, creating your stateful sets, scale sets, or elastic scale sets, using Helm charts. So again, it's that crawl, walk, run mentality behind it, because it's a big task to take a very large application of HealthShare and making it containerized, if you will. So where can we go with just Docker and Docker Compose? So you can certainly run bare metal, ECS, just straight up Amazon EC2 instances, Azure Container Services, which is basically just a VM in itself, and then Google Compute Engines. A lot of different scenarios you can go here with this, but again, this is where we're initially thinking of doing that. So for now, we're going to move on to Renan's going to show us a demonstration of what Docker and Docker Compose is going to do for us, and then we'll come back to do a discussion on Kubernetes here.
Buckle up. This is gonna be a lot of reading small things on the screen. I'm gonna walk you through most of it so you don't need to force your eyes. But basically, this is actually going several steps back from what you saw this morning. So this morning, it was more about quickly deploying, leveraging some of the components Mark just told, AWS, Helm charts, and, deploying in Kubernetes. So all that, it was what made that demo possible. Now we are stepping back to the basics, where we are just working with pure containers and Docker Compose. And, I'm going to show exactly what that looks like a little bit, just so you understand what is behind the scenes and where we can start parameterizing things to actually make an instance that it starts as a raw install kit, as a one-to-one, as Mark mentioned, for what we have as a kit today, and becomes an actual component, something that can be used out of the gate. So because this will take some time to spin up, I'm just going to actually spin up this Docker Compose file I have here. Actually, this is bringing down, so let's bring it up. This is going to deploy 4 components, if I still know how to count. this is going to be a registry, a ODS, an edge, and a viewer all together. So let me walk you through what exactly this Docker Compose looks like. And I try to make this a little bit easier to read why this is happening. So a few things we don't really care too much about for this demonstration, but just so you know, we are using a web gateway, dedicated app gateway for each component. So this is the first piece you see here. Now going more into details of each HealthShare component we are deploying, the first one here, it's the registry. So as Mark mentioned before, we have a one-to-one relation of the install kit and a base image at this point. So what I'm doing here is using a base image for HealthShare Unified Care Record. So this base image allows me to then deploy pretty much every component you would expect in separate images. And what I'm doing here is, because I can introduce some, parameters, I'm saying, okay, out of this UCR base image, what type of component do I want to deploy? And this is a registry for that instance. What is the namespace of my component? And what is going to be the web host? Because in this case, I'm using a dedicated web gateway to deploy that. So there are a few parameters in here that are important. Another ones that if you had the chance to work with Ars and Ars for Health in containers, you might be familiar. So one of them is the CPF merge that allows me, to change a few things on the CPF configuration file. And the other one is the persistency. So here I can inform, for instance, the IC data directory parameter that allows me to have databases to be persisted. And when we are talking about containers on HealthShare, this is a must. I mean, there's no way around. We need to persist the data for several reasons. So in here, we see some of the parameters that makes up for a registry deployment. So moving forward, I have, as I mentioned, a dedicated web gateway per container. So for my second container, I'm still using the same base image as I was using to create the registry. But only this time, I'm not creating a registry. I'm creating an ODS. And following sort of the same steps, I have my type as an ODS. I give it a namespace for my deployment. And because I want to automate this deployment to the extent you've seen this morning, where things know where the other things are, I'm telling, okay, here is where my registry is. So when you start up, you just communicate with it and make it happen. So I'm informing where is my registry leaving, what is the namespace of my registry, and which port is it listening to. So I have a few steps there that will guarantee. And then a few of the other normal things are going to show in a little bit the persistent bit of it. But in here, I'm just, for this demonstration, I'm saving some of the databases in my file system so we can see, how that all gets created. Likewise, I have yet another use of the UCR base image, where this time I'm creating an edge. So my type is edge, my namespace happens to be my edge, and following sort of the same steps, I'm informing the edge where the registry is. So it knows again how to communicate. And the last one I have is a different base image. This time I'm using a clinical viewer image. So same thing, what can I do with a clinical viewer image? Well, right now deploy the clinical viewer. So this is pretty much what I'm doing here. So just say, okay, it's the viewer. If tomorrow we decide that there is another component for the clinical viewer, we could just change the parameter type in here. And same things, to be consistent, namespace, what is the web host, where is the registry is. So this pretty much, represents sort of where my all my information is. And actually, this shouldn't be here because I wanted to show that later. Let's see, how can I do that? So I'm gonna actually try to just remove one component and see how that goes. Didn't care. But anyways, we should see. Okay, so here are my instances. They're now up and running. I can actually, let me close this guy and this guy. And if we do a Docker PS, we can see a lot of stuff. So as I mentioned, so there will be here because I have an extra 10 images. So 10 HealthShare components, 10 web gateways, one for each. So that's why you see a lot of stuff, but basically just saying, this is an image, the base image where it came from. We can probably find the name. Where's the name of my container? Somewhere down here.
Yeah, it's on the second row.
Oh yeah, it's here. It's hard to see. So I have, Edge 2, ODS, Edge, so on and so forth. So all the containers right here. Now I can access them and see, how this all works. So I start by accessing my registry. So that's super user. And this is a new deployment, so it will ask for a password. I come in and there is nothing, as you would expect. Well, not quite like. I already have a registry deployed. The only thing is that it's not started, and it's not started on purpose. So for now, we don't want to just start something. Maybe you're putting this on production and suddenly you have data flowing around that you're not even sure you want it to be flowing around. So we are just deploying something that is still not function, but you can simply start. And that should just get your production off the ground. So now let's see how the communication between those components work. So if I go to my service registry here, it's empty. I still don't have any component trying to talk to the registry. So let's make that happen. So now go to my ODS, probably blank, yeah. Same thing, new deployment, just have to access. And again, that's empty installation with the ODS deployed. And just before I start, actually, let me go to the installer wizard. We can see here that based on the, let me see if I can increase that. So based on the parameters that I have informed, it already knows, okay, HS registry is the namespace of my hub. This is where the registry is listening. Because it's port 80, makes it nice and neat, so I don't need to inform the port. And we have the URL to where the registry is. So if I go back and start this, okay, so now this is actually not too good. Hopefully it's running on the background. Where is that? Okay. Well, that's starting. We should see, yeah. So we're already seeing that something is happening. ODS is starting to communicate with, yeah, it's complaining that it's already running. If we go back to homepage, we should see. And we should have another entry right here, the ODS. Same thing true for the edge. Go here, super user. Okay, I start the edge. That's my edge. And while the edge is starting, I want to also start my clinical viewer. So all instances are now talking to each other just by passing the parameters, to a Docker Compose file. Similarly, we could do that, and we did that, in fact, this morning. We can parameterize through the YAML files that composes a configuration that is going to Kubernetes. So when you use Helm charts, you can make it even better in ways you can parameterize that. And then when you're deploying, you can, based on the control plane you see, you select, I want this, this, and that. It just do it for us. So that's where we want to go. This is how we make it happen. So I start the viewer. Did I? No. So I'm still doing it. Now, if you look at here, we probably have a lot more. So the edge has synced, the viewer is syncing, and everything is talking to each other. So let's test that. I do have a payload here, just a bunch of HL7. My edge is actually already up. I just drop that in and pray. Well, yeah, did work. Strong prayer. So where's my thing? Here. So now if we go to the edge, we can actually, or should actually, see the message going through there. And we do see a bunch of breakdown messages going through the file service pipeline. And if we go to the clinical viewer just started, we can actually go to the patient, and we're going to see, I think, most likely one of the most famous patients we have. That's Smith, actually. Yeah, and we can see that information is already there. So that actually shows you that, with a simple command, because actually all that I had to do once my Docker Compose file was done was to do a Docker Compose up, and everything got created. And that's basically the spirit of where we want to go. It's with something as simple as one command, a couple of parameters that on a nice UI would be even better, because now you have freedom of choice when you're configuring this stuff you need. And once you hit go, you have your deployment done. And as I said before, we embed all the best practices we have into that configuration. So now when we stand up the environment, things like, okay, the namespace where maybe your file paths are licensed and all that, you can provide, but then based on volume or other components that not necessarily have to be all that clear when you're doing all that, we can decide then, okay, this is the size of the machine we're gonna have to provision to spin up this container. So putting all that together helps us make it consistent in a way that every time we deploy our product will be always the best deployment possible we can have. So that's one of the goals we have with this. So I'll thank you all, and that's pretty much it for me.
Yep. So as you can see with that demonstration is the power behind Docker and the Docker Compose file, and the CPF merge, what I mentioned earlier about hardening your configuration, standardizing. So within the CPF merge file, you could put things like global buffers and enabling async IO and routine buffers and creating other parameter defaults for your deployment. And you don't have to have just one Docker Compose file. You can have multiple Docker Compose files. So in Renan's example, he was running everything all on his laptop on a single instance. So if you're going to have multiple machines, you'll have multiple Docker Compose files based on what you want to be running on that physical host. So now where we might want to go to, and I say future here, but again, it's a loose term. It's where we might go. But the goal is supporting EKS, OpenShift, Rancher, Tanzu, so that way we don't want to be doing any type of vendor lock, at least not yet. But will that happen? Will it not? It remains to be seen. And again, we'd love to hear your feedback on that. The difference being between this is instead of what you might be using ICM or our InterSystems Cloud Manager, you'll be using this with our Kubernetes operator instead. And what a deployment would look like. So instead of having a pod in a Kubernetes realm is kind of equivalent to a container, but a pod can have more than one container. So as Renan was showing earlier, where we have the web gateway with each of the other HealthShare instances, that would be considered a pod. So each pod, say if you have a registry, the registry pod would have 2 containers associated with it. But the goal here is with Kubernetes and with any cloud native is, and using cloud anything, cloud becomes economical when you're using everything that you're paying for and turning off resources when you're not using it. So here in this example, we can consolidate down as much as you can to as few physical nodes on the bottom tier here we have. So these are actual hardware nodes or EC2 instances within AWS of the actual compute resources provision. And you can scale them out as well. And then there's things you can do within Kubernetes to relocate a pod from one host to another. Or you can get into a little bit more exotic. So here's like a secondary option where you might say, well, I want 2 different Kubernetes clusters. And the difference between them is you might have different configurations or different resources allocated per node in each cluster. So on the bottom tier here, we might have more of the larger and what I'd call the static pod. So your registry, maybe edge gateways, things that are going to be pretty consistent and flat in terms of their resource consumption. You might want to put them in a larger but maybe smaller number of nodes and run it. And you can add nodes again dynamically as you need to. And that's one of the benefits of Kubernetes is you can just add another compute node or what they call a worker node into the cluster, and you can do the pod shuffle, if you will. The one on top is maybe a secondary one, and these are going to be things that are more elastic, and this is where you'll benefit from compute savings. And this is our access gateways, your buses, clinical viewer, things like that, where you may want to have smaller nodes or even larger ones. It's all relative, but it's going to be much more volatile in terms of elasticity. So that throughout a day you might be adding and reducing nodes and pods throughout the day, maximizing your utilization. Because going back to the old paradigm where if you're sizing something on-prem, you're buying capital expenditure for hardware, you want to size for X number of years of growth, you're running that machine basically at 40-50% utilization. So you have the headroom either down the road or unpredictable spikes in workload. In cloud, you don't want to be doing that because you're wasting money, because then you're only using half of what you're paying for. And this is where the elasticity model really comes into play and helps you out. So going back to that diagram I showed you earlier. So this is basically what it would be, is the two different groupings. So we would, on the top tier, which were those smaller Kubernetes nodes, we would have the elastic load balanced ones. And then in the lower tier, they'd be the static ones, whether it's quasi-elastic, edge gateways, document repositories, or the registry, Health Insight, things like that. Or you take it even a step further. So you can have heterogeneous type clusters where you have different size nodes within the same cluster, but then you can set up scheduling rules that says, okay, of this type of pod, you have a label of this. I'm only going to allow you to be scheduled on a larger sized node, or you're only going to be going on a smaller sized node. And that's when you get into the more exotic features of Kubernetes with labels and node selector capabilities. So in this scenario, again, going back to this thing, so now it's all based off node assignments, but with labels that are associated to a container, a pod. So you can have a lot of different mixtures. One I should put up here, and I actually think it's one of my favorites, is actually the hybrid model, where you might not run everything in a container or Kubernetes. So things like that are going to be static, absolutely static. Say, for example, the registry. And again, this is in the HealthShare as is, not some things we're potentially working on down the road. But you may just want to run those in a straight up EC2 instance, just mirrored. You know what the profile is going to be. It's very predictable for the most part throughout the day. And then maybe you only want to use Kubernetes for the things that are only elastic and dynamic, and that way you scale your access gateways, clinical viewers, because those workloads tend to be very volatile. It may be predictable in terms of 8 a.m. in the morning, workload comes up, you have a little bit of a valley over lunch, and then spikes up again from 1 to 3, and then drops off after 4 o'clock and again till the next day. So then you can again scale your resources up and down and reduce your actual cloud spend per month. So some general design and scaling thoughts. I talked about labels. So these are actually very important in conjunction with using our Kubernetes operator. They're defined for two things. One is for elastic scalability, for adding more compute nodes for the access gateways and clinical viewer, and also setting up anti-affinity rules for your scale sets, because you really don't ever want to have, say, a mirror pair of your registry and the stateful set deployed on the same physical node. You lose that one node, you're losing both mirrors. So the IKO in combination with labels prevents that from happening through anti-affinity rules. Some other things we're thinking about, and these are more the day 2 operational things. So monitoring, our goal is to leverage SAM. I don't know if anyone uses SAM today or not, but this could be and probably will be leveraged explicitly within this, because there are going to be so many more moving parts, especially in a Kubernetes or container-based environment. Having that nice centralized monitoring capability is going to come into play. Now, it doesn't mean we're going to force you to use SAM or anything like that, because we do have our RESTful API integration. So if you want to use CloudWatch or Azure Monitor, or Splunk, or any one of these other things, we can support those now because we do have full REST API capabilities. You want to deploy your own Prometheus and Grafana, knock yourself out. That works as well. System performance, or formerly P buttons, still available. We do, in our base images, we are loading the systat packages. So that way system performance or P buttons still runs cleanly. We have all the packages at the container OS level preloaded in there, so you don't have to worry about those. Backups is an interesting discussion, especially in a Kubernetes or even a container-based environment, because containers really aren't meant, it doesn't mean you can't, to have very large data volumes associated with the containers. Are meant, really small, little componentized nuggets. But running in a fully containerized environment, especially in Kubernetes, Valero seems to be the golden standard. It is a freeware, open source type thing, but pretty much anyone that's using Kubernetes is using it because it provides all the enterprise-based features, pre and post exec, so you can run the external freeze and thaw APIs within the container, so that way IRS, you get a clean backup of all your persistent volume claims, and everything is just clean and repeatable. So a couple key takeaways. We are rapidly evolving in this. So again, I want to stress, anything that we talk about today isn't set in stone by any means. This is where we're thinking, and this is where we're heading. We do want to take a phased approach and even a incremental step. The first one we have in mind off the rung is going to be patient index as the first candidate. And then doesn't mean that's going to be the only one potentially for this fall release, but that's the first one we're going to be focusing on, and then we'll roll on through the components as we go throughout the year in our sprint cycles. And again, please love to hear your feedback. You can certainly email me, Renan, any of your account teams if you want to have a more in-depth discussion, what plans you might want to have for a Kubernetes-based deployment. Because one thing I'll be honest with you is, in a lot of discussions we have with customers, one of the big goals to using containers in Kubernetes is almost a personnel hiring strategy. Is that no one's, I don't say no one, but there's very few people actually looking for system admins anymore. Traditional Unix admins and storage admins, they're looking to buy the DevOps type people that just know Kubernetes and, hey, I want to deploy it and I want to just make it work. And that's what we're hearing a lot from, especially from our larger customers as well. So a couple links up here. Hopefully they'll come through. I think you can download the slides, but there's some related documentation here about containers, our ICM, IKO, SAM. Docker and Kubernetes documentation is excellent, and it really gives you a good understanding. And there's actually really good YouTube videos from, I forget the woman's name. She has a great series on explaining all the little different nuances of Kubernetes and specific tasks. So it's certainly worth a look at on there as well. So if you have no Kubernetes experience. Here's how to reach Renan and myself. You can certainly reach us email, LinkedIn. And with that, thank you. And any questions?
But I have a question of curiosity. How much of what you've done is, shall we say, InterSystems specific? I mean, obviously, if anybody can just adopt the post lab, nodes, what is it we're doing to make this InterSystems specific as opposed to just something?
Well, there's some things that HealthShare itself does that doesn't make it as is right now out of the box doesn't make it really container friendly, because there's some things we put under the MGR directory, for example, um, that conflicts with how the Iris Data Platform handles what we call durable sys. And there's some things there where we have to jiggle it a little bit. So if you just took a straight up HealthShare release, 22.1 release that's available right now, and did your own Docker file, or your own Docker file to build your own base image, it won't work. Beyond starting that container one time, as soon as you shut that down, there's some data that you would think is persistent isn't, and that's the key when it comes to HealthShare when it containerizing it, is making sure the components we want to be persistent on a container lifecycle or restart maintains being persistent, and that's where the challenge is coming in. Sure.
So I know Docker and Red Hat don't have a good relationship moving forward. Is the intent to at some point adopt Podman?
Podman is Podman. It's a different beast for sure. Renan and I, we actually had a discussion about this earlier today, where there's claim of backwards compatibility. It's just different. So the short answer is no. So what we're shooting for out of the gate is Docker as the runtime engine. There's no issues because the UBI 8 image that we're using is OCI compliant. So that way, running it in Docker or Containerd or Podman itself works, but for now we're sticking with Docker as the first shot. Any other questions? We got the lunch hangover. But I mean, if you certainly feel free afterwards, you see Renan and I. Oh, you're loaded. He's a plant here. Short answer, yes. Not specific to HealthShare. So just Iris specific, or I'll say Iris general workloads in a container. Out of the gate, there was, but we have learned a lot of things over time that there's some specific flags and switches that need to be used when initiating the container that need to be enabled, and performance is on par with if you're running it on the same host versus running it in a container. Performance, we expect it to be the same.
And to add to that, the good thing about the way we're doing things is that we are leveraging a lot of the Iris and Iris for Health experience with working with containers. So a lot of the questions that have been asked then should be answered by now, and we should leverage those answers as well. So we are not starting completely fresh. Right. We're coming from experience just across the room. So
yeah, and even the process. So Iris has been building containers for 4 years now. I think 2018. Yeah, so 4 years. So again, there's a lot of lessons learned. The same general recipe that's used to build those containers is pretty much the same process that's being used to build the HealthShare containers. So we're not completely divergent from each other in terms of, Iris Data Platforms is doing it this way versus HealthShare doing it this way. And there's one other important point is the question to be, well, why aren't you installing HealthShare just on top of Iris, which is already containerized, blah, blah, blah. Two answers to that. One, there's a long one. The short one is because HealthShare has they build their own kits, and it's been that way since the beginning of HealthShare, where HealthShare made its own install kits. It's not a case of installing it into HealthShare. That may change in the future, but there's no immediate plans right now. Any other questions?
I'll ask a good rhetorical one. So since you guys have shown it, does that mean that a customer can grab a Red Hat UBI image and install HealthShare into it in production?
No. I hope that was the answer you were looking for. But no, it goes back to, because there are changes that are necessary in the product for it to work, to be containerized successfully. There have been, and even our own sales engineers have been guilty of this, and going cowboy on throwing it in there and making it happen. But the durability is in question beyond that with the data.
There are other ways to make people suffer. Please don't ask anyone to do that. So yeah.
Anything else? All right, great. Thank you very much.
Thank you.